Hi everyone, it's Mrs. Meehan, and in this screencast I will go over Newton's third law of motion. Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. So anytime a force is exerted on an object, that force is caused by another object. So there must be two objects involved to have a force. Looking at the example below, we have a cat taking a nap on the table. We have two objects involved. One is the cat and the other is the table. So for Newton's third law here, the forces here are the force exerted on the cat by the table, upwards, and the force exerted on the table by the cat, downwards. So two equal forces in opposite directions between two different objects. So whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. There is another way to state this, and this might sound familiar from past courses. For every action, there is an equal and opposite reaction. And remember, forces, or actions, are always applied to two different objects. So this is the key to the correct application of the third law. There must be forces exerted on different objects. Make sure you don't use them as if they were acting on the same object. Then they would add to 0. So down here, the two objects would be the hands of this person here and the floor. So in this action-reaction pair, we have the force on the hands by the floor and the force on the floor by the hands. And they are in equal and opposite directions, upward versus downwards. Now, rocket propulsion can also be explained using Newton's third law. Hot gases from combustion spew out of the tail of the rocket at high speeds. The reaction force is what propels the rocket. So the action here is the force on the hot combustion gases on the gases of the atmosphere here. And the reaction force is the force of the gases onto the combustion gases. So note that the rocket does not need anything like the Earth to push against, since the two different objects in this case are the combustion gases against the gases in the atmosphere. Subscripts can help keep your ideas and equations clear. So the first subscript here, we have GP, let's say, is the object that the force is being exerted on. So here G is representing ground. And the second is the source of that force. P is person. So in this diagram below, we have the horizontal force exerted on the ground by person's foot. So that's your FGP. On the other side, we have the horizontal force exerted on the person's foot by the ground, and it is in the opposite direction. So that is represented by negative FPG, since it is the horizontal force exerted on the person's foot, P, by the ground, G. You can also note it here, it is just showing you the vectors themselves pointing in opposite directions. When we write it out algebraically, we'll be using positive and negative signs to indicate negative versus positive directions, left versus right, up versus down, etc. Let's try a couple practice problems. So an object of mass m sits on a flat table. The Earth pulls on this object with force mg. Remember, that's mass times gravity, which is the same thing as weight, which we will call the action force. What is the reaction force? The correct answer is D. So remember, we have two different forces here, or two objects, sorry. So we have the Earth and we have the object on the table. So the action force is the Earth pulling on the object. So that is downward. The opposite reaction force would be the object pulling upward on the Earth with force mg. So an equal and opposite reaction between two different objects. A 20-ton truck collides with a 1,500-pound car and causes a lot of damage to the car. Since a lot of damage is done on the car, the correct answer is B. So taking a closer look, the force on the truck is equal to the force on the car. Since we're talking about Newton's third law, no matter the size of the objects, the force between them will be equal, just in opposite directions. As you are sitting in a chair, you feel the chair pushing up on you. The reaction force in this situation is the correct answer is C, you pushing down on the chair. Since the action force is the chair pushing up on you, then the reaction force is you pushing down on the chair. A student is doing a handstand. A reaction pair of forces is best described as the correct answer is A. So remember, an action-reaction pair here, we need to have two different objects involved. So for letter A here, we have the student, and they're pushing down on the ground. And then the ground pushes up on the student. So we see an action-reaction pair in choice A. We have our equal and opposite forces between two different objects. Which of Newton's laws best explains why motorists should wear seatbelts? The correct answer is A, the first law of motion. Now remember, the first law of motion generally states that an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by a net force. So remember, this one is also called the law of inertia. And inertia, recall, is a measure of an object's resistance to motion. So going back to how an object in motion remains in motion, an object at rest remains in rest unless acted upon by a net force. In this example, let's say you are in a vehicle and you're not wearing a seatbelt, you are not anchored to that vehicle in any way. So whatever force, whatever net force is acted on the vehicle will not apply to you. You are an object that is independent to the forces that act upon the vehicle. So if a net force was applied to a car, whether it's hitting the brakes quickly or a collision and it rapidly comes to a stop, that force is not acting on you and your velocity would continue. You would not experience any acceleration since that force did not apply to you. If you blow up a balloon and then release it, the balloon will fly away. This is an illustration of the correct answer is C, Newton's third law. So here we have an action-reaction pair. It's going to be the air in the balloon against the air outside of the balloon. So if you blew up that balloon and released it, so you let go, then the air will rapidly leave that balloon. So there will be a force of the air inside the balloon on the air outside the balloon. There will be a reaction force in the equal and opposite direction of the air outside of the balloon on the air leaving the balloon. So since we have an action-reaction pair involved, then Newton's third law is the best choice. So there are no further practice problems for this lesson. Just be sure to complete Newton's second law quiz this week. And remember, contact me anytime if you have any questions on anything from this lesson or anything with the homework quiz.